In this video, I would like to introduce you with different password cracking methods. First of all, let's review how the whole cracking process works. As you know, hash is one-way function and it is impossible to convert it back to clear text password. So to crack the hash, we have to use another method. Let's imagine that we have a password hash, which must be cracked. Also, we have all possible password combinations composed of alphabet letters, numbers and other symbols. We take the first password and calculate its hash. Then, this hash is compared with our hash which we want to crack. If both hashes are identical, we can say for sure that correct password is found. If they mismatch, we repeat the same process but with other password. As you can see, the cracking process is not complicated, but it's time consuming. The stronger password, the more time we need to crack it. To speed up the cracking process, we can use the following methods. In dictionary method, we use a special list of passwords to calculate hash. As you know, many people use simple words to create passwords. For example, name of children, months, birthdays, name of pets, and so on. Dictionary lists contain all possible combinations of words on different languages. Dictionary method is easy and relatively fast, but it's not suitable if password contains special symbols and numbers. Besides, the success of attack entirely depends on content of dictionary. Brute force attack is useful to crack any password with any complexity. It dynamically creates the list of all possible password combinations, including letters, symbols, and numbers. But it's a very slow method. Hybrid method is useful when one half of password consists of word and other one consists of different symbols. So the first part of password can be cracked with dictionary method, the second one with brute force attack. The last type of password attack is rainbow tables. The idea is to have the list of pre-computed pairs of password and hash. But the problem is that it is necessary to have a huge memory space to keep all possible hashes. That is why rainbow tables use special index chains to essentially reduce memory space. Let's see how these chains look. To create the chains, we need two functions. It's a hash function which calculates the hash from the password, and reduction function which is used to calculate new password from the hash. Please note that reduction function does not restore initial password, it just creates the new one. Let's imagine that we have this password. Using hash function, we create new hash. Then, with reduction function, we create another new password. And then we repeat the same procedure with the hash and reduction functions. As a result, we have long sequence with the passwords and their hashes. This sequence is called chain. We can have many chains, and each chain can consist of hundreds and thousands of passwords and hashes. But there is one problem. The longer chain we have, the more memory space we need to keep it. That is why rainbow tables keeps only first and last passwords of each chain. Having this data, we can easily restore the whole chain. Just imagine, if one chain consists of 1000 passwords, we can essentially save our memory space just keeping only 2 passwords. Now let's try to restore the password from the hash. The whole process consists of several steps. We have the following table. It consists of 4 chains. And we need to crack this hash. As the first step, we use reduction function to get the new password from our hash. Now, we need to find if this password is presented in the second column of rainbow table. Well, nothing is found. Let's try to get the new password. First, we need to calculate the hash of given password. And then, from this hash, we compute another new password. And again, we try to find any match in the table. This time the password is found. So we found the right chain, and this chain has the password for our hash. All we need to do is to restore the whole chain, starting from the first password. So sequentially we use the hash and reduction functions unless we found the same hash we want to crack. When we find the hash, we find the password. So this is the whole process. I hope you are clear now how rainbow tables can be used in password cracking. And this is a block diagram to better understand the whole process.